like to introduce tonight's guest speaker, Mr. Robert Reeves. I had the pleasure of listening to this talk last week at the El Dorado Star Party, and it was just absolutely inspiring to me. So I'm glad that we were able to get Robert to come talk to HAS this week, and really looking forward to it. Many of you know Robert, but for those who don't, Robert's been exploring the cosmos since 1958. He had his birthday yesterday. Happy birthday, Robert. And took his first lunar photograph in 1959. He began telescopic astronomy with a 4-inch Criterion Dynascope, his Christmas present in 1960. In 1975, he acquired a Celestron 8 telescope, which he still uses today. In 1977, Robert acquired a Celestron 8-inch Schmidt camera that he used for a quarter century for deep sky photography. Today, Robert uses the Celestron 11 Edge HD and a Skywatcher 180mm Maksutov for lunar photography from his Perspective Observatory located in Central Texas. Robert also uses a Skywatcher 20-inch Stargate telescope for visual observing and a Celestron 14 with a HyperStar for deep sky photography. In 1984, Robert began publishing articles about astrophotography in Astronomy magazine. Since then, Robert's published over 250 magazine articles and 250 newspaper columns about astronomy. His articles have appeared in Sky and Telescope, Astronomy, Deep Sky Journal, Amateur Astronomy, and the Astrograph. In 1994, Robert published his first book, The Superpower Space Race, followed by The Conquest of Space, co-authored with Fritz Bonner. In 2000, Robert published The Widesfield Astrophotography, followed by Introduction to Digital Astrophotography in 2005, and Introduction to Webcam Astrophotography in 2006. One interesting tidbit I found out, asteroid 26591, Robert Reeves is named in his honor, and asteroid 26592, Mary Renfro, bears his wife's name. Robert and Mary are the only husband and wife team to have sequentially numbered asteroids named after them. If you've ever been to any of the local star parties, the Texas Star Party, Alcon, the Arizona Science and Astronomy Expo, lots of other places, you've probably seen Robert's name posted there. But he's a wonderful speaker, and we're really delighted to have him here with us tonight. And so, Robert, I'd like to stop the share here and pass it over to you. Thank you.
All righty, let's see if we can make this work. Going to screen share, and hopefully you see my title slide, correct?
You can see the title slide and a few objects in the back. Yes.
Okay, let's push one more button and should be full screen now, title slide.
Full screen indeed, yes. And I just wanted to let people know that if you have questions of Robert, please use the chat function within Zoom, post your questions there, and we will get to those at the end of the presentation. Thank you.
All righty, well, here, I wish that would stop doing that. There, okay. Now, this title of the talk was originally Postcards from the Moon, because, you know, everybody knows that I've had a long love affair with the moon. But lately, I've been having an awful lot of fun doing urban deep sky astrophotography right here in San Antonio. And I know not everybody is an astrophotographer, so I don't want to dwell on this, but I felt compelled to add a little bit to this presentation, the beginning of it, and talk a little bit about how you can do significant, serious deep sky astrophotography from inside the city nowadays. Just 5 years ago, this was impossible. Now I can do better astrophotography from Terrell Hills in San Antonio. And if you're familiar with the San Antonio map, I am well inside Loop 410. And I do better astrophotography from home now than I used to be able to do at the Texas Star Party. So this is a serious, significant leap in technology, and it deserves a little bit of mention. So not only is this a victory for astronomy where technology defeats light pollution, it brings astrophotography home to you. You don't need to travel 100 miles to do this. You can do it anytime it's clear from your backyard, which opens up enormous opportunities. The filter that I use, I'll explain, is rather expensive, but in the several years that I've been using it, it has more than paid for itself in gas savings alone for the amount of photography I do. I mean, clearly I can't go out of town every clear night, but I can use my observatory every clear night. So Like I said, all these pictures were taken from Terrell Hills. I use a ZWO ASI 294 MC Pro camera with a Radian Filters Triad Ultra light pollution filter. This is mounted on a HyperStar on a C14. And as your astrophotographers know, the HyperStar replaces the normal Schmidt-Cassegrain secondary mirror and converts the 14-inch f11 telescope into a 14-inch f2 astrograph. And this is the beast on top of my garage here in San Antonio. I've got a large deck built on top of the garage, significant railing around it, so I can continue doing astrophotography in the future. And the observatory itself is a roll-off building that rolls off on tracks to expose the telescope. And everybody recognizes internationally famous Pranvera Hysini checking out my C14 because she knows she's getting one for her observatory in Kosovo very soon. Now, that's what it looks like from the ground, looking up top of my garage, regular old 2-car garage, big deck up there. The building rolls off to the east. I push a button downstairs, the hatch opens electrically. Up the stairs I go, and I'm in the observatory. Pier goes down through the roof, doesn't touch anything. It goes down through the base of a turbine vent that does not have a turbine on it, so that it kind of shields it from weather. The building being on top of it prevents rain from going down. And the whole system is set up on a steel platform that rests on the floor of the garage. It's not anchored down, just the mere mass of all the steel is enough to support the telescope and keep it steady. So I have a lot of fun up there. It's all remote operated from inside the house. I have to physically open it and turn on the power, but after that I can operate everything from inside the house. The interior of the observatory, complete with the spare telescope in the corner, the Celestron 11 that I use on the moon. The 14 is strictly used as an astrograph. And the 14 set up with the HyperStar option ready to go. Now, the key to the whole thing here is this Triad Ultra quad band narrowband filter. Originally, they had the first quad band, but now they have a newer version that is designed for very fast systems, F3, and that works much better with the HyperStar, because the original version at very short focal lengths had a significant amount of spectral roll-off because of the short focal length, and we were losing portions of the H-alpha. This new F3 filter cures that, and the H-alpha signal is a lot stronger with short focal lengths. Visually, the filter is opaque. I mean, it looks like a mirror. I mean, you could use it as a shaving mirror. It is not a visual filter. It lets through very, very narrow band passes in the H beta, oxygen 3, hydrogen alpha, and sulfur 2. The band passes are something like 3 nanometers. The filter is extremely aggressive. Before I put the telescope up on top of the garage, I would use it in the driveway, roll it out of the garage on a wheel platform. And one night my wife drove down the driveway while the telescope is exposing a deep sky object. She has a Buick with extremely bright, brilliant headlights. And I thought, okay, well, that sub-exposure is gone. When I looked at all the sub-exposures, I could not tell which one was flashed by her car. My typical exposures are 4 minutes from inside San Antonio at f2. And I have lots of histogram left. My exposures could theoretically be longer. Right now I'm focusing using a Badanov mask, a split mask that John Bozeman made for me. And it clamshells onto the HyperStar. And most people know what a Badanov mask is. I am in the final stages of mastering the Nina software package, which will add autofocus capability. So I'll be able to do away with the mask and do all of my focusing from inside. I operate the telescope from my desk here inside the house via Wi-Fi, because it's not that far away. It's tied in with the same Wi-Fi as the whole house. And of course, everybody's familiar with the Batonov masks. When you adjust the focus so the center bar is exactly in the center of the X pattern where you're in focus. So what does this thing do from the middle of town? Clusters, galaxies, emission nebula are easy. One thing that this filter does not work on is reflection nebula. When you take a long exposure of the Pleiades, you get stars. The blue reflection nebula does not fit the bandpass of the filter, but everything else comes through pretty good. M7, Ptolemy's cluster. Notice the dark nebula running dog underneath the cluster. Anytime you can see the propeller embedded on M13, you're doing good. This from the center of San Antonio. M35 and its little companion cluster, 2158. The same with M46, M47, and the little companion planetary, NGC 2438. Crab Nebula shines through like a searchlight. Galaxies, they don't quite fit the bandpass, but if you expose longer, you do get good results. Trio and Leo, M81, M82, and then of course NGC 3077, the little galaxy that all novices think is a comet they just discovered, but sadly it's been seen for centuries. Pinwheel Galaxy at 675 millimeters focal length. The sombrero is kind of small, but I really like how it turns out. It's really nice looking. Whoops, wrong direction. Probably overexposed, the triangular galaxy. And Andromeda from my backyard right here in San Antonio. Nebula is where, emission nebula is where this filter really shines. Horsehead Nebula, Flame Nebula up above it, probably be better processed. Orion, M42, looks almost alien because this filter is picking up so many things that we normally don't see. The nebula almost looks like a clam to me, and this an open clam. Rosette, oh, you can't do better anywhere. Oops. The Monkey Head Nebula, the bright, large nebula up at the head of Orion. Seagull Nebula down in Monoceros. Pac-Man Nebula, one of those nebulas that I named back in the 1980s in a Deep Sky article, and the name stuck, or Deep Sky magazine article, and the name has stuck. The Bubble Nebula, which I did not name. California Nebula. Tadpoles Nebula, just now rising over in the northeast. Jellyfish Nebula, going to be a good target here in about another month or two. Lagoon Nebula, almost overexposed from the middle of town. M20, the little companion, M8 and the companion M20, Trifid Nebula. The Eagle Nebula, and at 675 millimeters focal length, I'm kind of happy to get the Pillars of Creation in there too. The Swan, upside down, but it's still the Swan. The Butterfly Nebula up in Cygnus. This is one of my more recent creations just within the past month. Pelican Nebula up by the North America. And then south of the Pelican, there's a rather extensive nebula complex that has no name except IC 5068, so I call it the Pelican's Nest. And part of the Veil Nebula, people call it the Veil, various other names. To me, it looks like a feather. I'll call it the Feather Nebula. Pickering's Triangle, the middle of the Veil, has always had that name, so I'll leave that be. But the other half of the Veil, it sure looks like a nice fat Gulf shrimp to me, so I call it the Shrimp Nebula. The Elephant Trunk Nebula embedded within the icy 1396 up in Cepheus, Crescent Nebula, Cygnus, Cocoon Nebula in Cygnus, the Mexico portion of the North America Nebula. North America is so big it does not fit in the field of view of the HyperStar. And concluding the deep sky photography section, the beauty of the night sky is infinite. We just need to know how to look at it. And with this new filter, and there are others available too, but at the moment, I believe the Triad Ultra quad band is the most aggressive filter that cuts out light pollution. But I'm sure others will be coming down the pike. Optolong has some that do pretty good, but so far for the skies that I have, like what I have, I can barely see Saturn, the center star in Cygnus. I can see the summer triangle, but picking out other things like trying to find a Big Dipper, that's a challenge. Yet this quad band triad filter cuts right through that, no issues. So it's something for you astrophotographers to really think about. You've got a lot of money sunk into your astrophotography gear, but you can only use it when you take it out of the country. When do you get to use that? Maybe 1 week in a month, if the weather is good. An investment into this filter will pay for itself in the amount of extra use you can get out of your equipment. So with that in our rearview mirror, now we shall look at the moon. My mission over the past number of years has been to try to reacquaint people with the moon, make it not that big bright thing to avoid because it blocks the night sky, but it's also a target to be considered. It's a rather marvelous object once you get to know it and understand it. So tonight we're going to explore the phases of the moon, how the moon appears through the month, the creation of the face of the moon, the lunar maria that make up the man and the character of the man in the moon, mysteries along the terminator. We will take voyages to the very popular landmark craters, Plato, Tycho, Copernicus, and Straight Wall. We'll investigate volcanic features, ghost craters, floor fractured craters, crater rays, odd-shaped craters, they're not all round, lunar valleys and mountains, scarps or cliffs, and the ever-changing moon. It's never the same 2 nights in a row. So starting off, the waxing crescent moon, I call this the Cheshire Cat moon. Remember the tale of Alice in Wonderland? The Cheshire Cat just faded away until there was nothing left except his smile. And that's what the crescent moon in the low in the western sky reminds me of. Initially, we'll first see Mare Crisium appear in the crescent moon, the first of the lunar Maria to appear. And Langrenus crater and Batavius crater are big enough that you can see them in binoculars. Getting up to the quarter moon, first quarter. Oops. Yeah, the left side of right side of my screen is hidden behind the people, so I wasn't seeing that the things were showing up. But hopefully you can see that we now label Crisium, Mare Crisium, Mare Fecunditatis, Mare Nectaris, Tranquillitatis, where Apollo 11 landed, of course, and Serenitatis. Serenitatis and Tranquillitatis, of course, together form the man in the moon's right eye, but we don't recognize that caricature quite yet. We have to get further over into the full moon before that feature begins to see. Now we see the most detail along the terminator, the sunrise, sunset line where day meets night. Here, the shadows reveal the relief of the features. If the moon is flatly lit at full moon, we lose those shadows. But during the phases, we follow the terminator and we see the greatest amount of detail. Getting up into the gibbous moon, waxing gibbous, more of the Mare are appearing. Imbrium now joins the fray, Mare Nubium, Humorum, Cognitum, one of the seas that were actually named during our lifetimes. Cognitum was named in 1964. Mare Insularum followed in 1970, I believe. And of course, now our landmark craters, the sentimental favorites everybody loves, Plato crater, Copernicus, Tycho, are now visible. Getting up to the full moon, if you back away from your computer about 25 feet, you can recognize the face of the man on the moon. Now we begin to study how the man in the face of the moon came into being. Now, two forces created the face of the man in the moon: asteroid impacts and subsequent volcanic modification of these features. Now, the moon's large basins, the circular impact basins that later filled with lava to form the face of the man on the moon. These were created by asteroid impacts during the Nectarian epoch, about 3.8 to 3.9 billion years ago. Initially, the moon was just a solid cratered wasteland. These maria did not exist at that time. They were formed over the next billion years when lava eruptions flooded into these basins between 3 and 3.8 billion years ago. Now, you have to realize the basins and the maria that lie within them are two separate features. They are not the same thing. Now, today we recognize these impact basins and the maria laying within them, but for 300 years of observational astronomy, astronomers did not understand what these were. They didn't understand how they came into being. It took geologists in the late 1800s to finally recognize it, but it was not universally accepted until literally into the space age during the lead up to the Apollo missions. Now, Mare Crisium follows the theme, a circular impact basin. It filled with basalt up to its brim. The Pyrenees Mountains form the eastern shore, the eastern rim of the basin. Within it, we see the wrinkle ridges, Dorsa Tetyaev, Dorsa Harker on the eastern shore, and the outlines of Dorsum Opal and Dorsum Termier on the western shore. These wrinkle ridges are formed when basalt slumps toward the center of the depressed middle of the basin. The mass of the basalt sinks the middle of the basin. The outer portions of the basalt slump toward the middle, and we get these wrinkle ridges. Crisium is fairly bland. The only large craters on it, Swift, Pierce, and Picard, and these are fairly small craters for the moon. Maria Nectaris follows the same theme, a circular impact basin filled with basalt. In this case, we have a little bit more action. We've got Theophilus, Cyrillus, Katharina craters, and Fracastorius craters along the rim. Progressing westward, Mare Imbrium appears to be the largest maria as seen from the Earth, but it's actually only the second largest. The Oceanus Procellarum is larger, but we see it at an extreme slant, so the foreshortening makes it less obvious. Imbrium forms the man in the moon's left eye and hosts Plato crater, the unusual snake-eyed crater Cassini, Archimedes crater, unusual, both Plato and Archimedes, unusual in that their centers are filled with basalt. Now, these lava flows did not overflow the rim of the crater and spill into it. This basalt forced up from underneath the crater through fractures in the crust created by the impact that created these craters. Indeed, the basalt layer in Archimedes is several hundred meters higher than the surrounding mare. So it's a very fierce volcanic action happening here. Humorum, again, same theme, circular impact basin filled with basalt. Gassendi crater, a very prominent floor fractured crater, is a landmark to the north, Doppelmayr to the south. Very distinctive craters that don't follow the theme of a normal bowl-shaped crater. And we'll explain these floor fractured craters later on. Not all impact basins filled completely with basalt. Mare Austral down on the southeastern limb of the moon is an example. Austral Basin is close to the thicker far side crust, and this thicker crust restricted volcanic eruptions and limited Mare Austral to just a collection of basalt-filled craters instead of a completely smoothed over, paved over parking lot like the near side Mare. Oceanus Procellarum. It dominates the western side of this view, and it is twice as large as Mare Imbrium, over 2 million, 2 million square kilometers. But it is so foreshortened to our view that it really doesn't even contribute much to the caricature of the man in the moon. But it's the only lunar Mare. Come on, get my thing to stay here. It's the only lunar Mare that's called an ocean instead of a sea. It's the largest, but as I said, it's very foreshortened, so it's diminished, but it does house some or host some very fascinating features. Aristarchus crater, one of the brightest on the moon. You can even see Aristarchus by Earthshine while it's still in the shadow. Copernicus crater, and of course Kepler crater. Now the ray structures from Aristarchus, Copernicus, and Kepler combined to form a bright pattern that we can see with the naked eye when we look up at the full moon. And other Mare hug the very limb of the moon. Mare Oriental hugs the western limb. And I've turned this picture sideways simply so it'll fit better on the screen. But here we see Mare Oriental on the very limb of the moon. And we see it at such a slant angle. You can see the elevated rim of the basin and the depressed floor where the basalt field is. Observationally, we also have Burgess crater in the foreground, very bright ray structure, and the Plato wannabe basalt-filled crater Kruger. Now, along the terminator, I mentioned that this is where the most detail is seen because the shadows are the greatest. We need these shadows to get relief, to see detail. And in this case, sometimes the shadows are so extreme that we almost don't recognize the crater. In this case, we've got Fracastorius crater, which we saw earlier is that crater at the bottom of Mare Nectaris, very ordinary looking crater, but they take on a very alien science fiction-y look when they're right on the terminator. And Piccolomini crater also joins it, a very ordinary crater, but in the deep shadows, it just takes on an entirely fascinating new personality. The same with the lunar strongmen, Atlas crater and Hercules crater. Look totally different when they're right at the sunrise or sunset, take on whole new personalities. Some craters that don't necessarily roll off the tip of the tongue, large but ignored, Pitiscus, Homel, Mutus, again, very ordinary craters when you see them fully lit, but very fascinating when they're deeply shadowed. The same with the eastern shore of Mare Nectaris, the Pyrenees Mountains, hugging the left-hand side of the screen. But we've also got Gutenberg crater, named after the inventor of the guy who perfected the printing press. Got Plinius, I forget who he was. He's significant, you know him, but I forget who he is. So we'll go on. Magelhanes, we all know him as the explorer Magellan. And then, of course, Colombo, named after Christophe Colomb, who we know in the West as Columbus, discoverer of the New World, if you ignore the Vikings. Now, some some craters like Janssen, they are so big they almost hide in plain sight, except when they're down low sun elevation and illuminated at sunrise or sunset. Then you see the relief of its rim and it shows up. Most people see Fabricius crater with no difficulty. Buried within it, a very large crater in its own right, about 70 kilometers in diameter. Janssen, over 200 kilometers in diameter, and Riemann Janssen arcing through it. People often see that, but don't recognize at high sun elevation, they're actually looking into one of the larger craters on the moon. The Theophilus, Cyrillus, and Katharina craters over on the western shore of Mare Nectaris. These make a very interesting study in the ages of lunar features. Now, these are all very similar in size and age. They're over 3 billion years old, yet one is totally destroyed. The other one doesn't look like it's in good shape, but the one on top, Theophilus, looks as fresh as it was made yesterday. So what happened here? Well, actually, yeah, come on, there we go. Katharina formed first and probably looked similar to what Theophilus looks like today. Soon after, Katharina formed, and the impact shock and ejector from it partially ruined Katharina. And then along comes the last one. In the same era, Theophilus formed, and the seismic shock of its formation and the ejecta wave ruined Cyrillus and further degraded Katharina. Now, all of these are very similar in age, but just the order in which they formed completely ruined the first ones and preserved the later ones. Now we're getting down to a little bit of tourist activity. Very popular craters, Plato, Copernicus, Tycho, the Straight Wall. These become sentimental favorites of both novices and experienced lunar observers. Now, Plato is distinctly different. Its surface completely paved over like a parking lot. Doesn't look like a normal crater. It's on the northern shore of Mare Imbrium, nestled between Imbrium and Mare Frigoris above it. The Cassini crater down below, very distinctive. Notice a W bond that just came up. Back up here. And so you make sure you recognize W bond. Notice it's almost square in shape. Not all craters are round. We have octagon-shaped craters, pentagon-shaped craters, bell-shaped craters, bullet-shaped craters. So you name it, it's up there. Now getting a little bit closer to Plato, now we begin to see the 4 little craterlets that are on the floor of Plato. If you see those in your telescope, you've got a good night of seeing going. It takes some really good seeing to spot these. The Alps Mountains next to Plato, and of course the Alpine Valley slicing through the Alps Mountains. And down below in Mare Imbrium, little Mount Pico and Mount Python poke up through the crust of Mare Imbrium, and these are strangely very beloved little craters. I mean, little mountains. People take a liking to them and kind of fall in love with them. And now another feature that most people don't recognize, Thor's hammer. We've all seen Agent Coulson on the movies and so forth, chasing after Thor, trying to get his hammer. Well, we can call Agent Coulson and tell him we have found it. Thor's hammer is on the moon, and it's an apparition that's been there all along, but just never had a name. So it's one of those little features that I've decided to put my own name on it. And if the name sticks, great. If it doesn't, well, that's the way it goes. But I call that Thor's hammer because it looks like a hammer laying on the moon. It's a mountain ridge, small mountain ridge, keyed into another one. And when the phase is right, it looks like the perfect impression of Mjolnir, Thor's hammer, just laying on the moon. Closer still, Now we're really seeing those craterlets inside of Plato, and the Alpine Valley. Whoop, didn't mean to do that. The Alpine Valley off to the right. If you're seeing that central rill in the Alpine Valley, well, cherish the night, because you've really got a good night of seeing going on. A very rare night of seeing. That rill is less than a kilometer wide, spans about 100 kilometers long through the Alpine Valley, but it is very narrow, and spotting it is a real good challenge for lunar seeing. Tycho, one of the youngest large craters on the moon, right square in the middle of the field of view, the freshest, most crisp-looking one in a sea of craters that are up to 40 times older than Tycho. The surrounding territory is all Nectarian or pre-Nectarian, almost 4 billion years old. Tycho itself has been dated by Apollo samples at about 108 million years old. Now, I'm not totally convinced of that 108 million year figure, particularly since it's based on such a limited sample. Six landings on the moon. Not that many samples to go by. So until we get more evidence, I'm just going to admit that Tycho is at least a 250 million years old. And if it turns out to be 108 million years old, well, so be it. I'll be very happy for that. But it is very young as far as a lunar crater goes. Oh, should have pointed it out. Sorry about that. I'm getting ahead of myself. But the surrounding craters, Longomontanus, Clavius, and them, are very old compared to Tycho. Now, getting closer, we see Tycho in the middle, but notice the surrounding territory. It's just almost rust-pitted with hundreds of tiny, tiny craterlets. These were all created by secondary impacts of the debris blasted out of Tycho that fell back onto the surface and created smaller craters. And getting even closer still, now we can see the central peak, the collapsed terrace walls, the streams of secondary craters radiating away from the Tycho impact. Copernicus, not necessarily the oldest, but perhaps the boldest of the craters. It's located on dark Maria, so it's more readily visible than Tycho. Tycho has a ray structure that spans 2,200 kilometers across the moon. Copernicus's ray structure is smaller, but it's on darker territory, so it shows up more. And it's a spectacular crater at sunrise. Sunrise breaking across Copernicus is something you will not forget. And the territory, we've got Mare Imbrium above, Eratosthenes crater, the Carpathian Mountains separating Mare Insularum from Mare Imbrium, secondary craters created by the Copernican impact, Mare Insularum, the Sea of Islands, so named because of all of the peaks protruding upward, and Reinhold crater down below. Straight Wall is not a crater, but it's high on the list of sentimental lunar favorites. It's actually a feature called a graben, where land on one side of a fault line has collapsed and slipped downward. Straight Wall spans a little over 100 kilometers on Mare Nubium. Come on, there we go. To place it, it is just south of our Zatchel crater. The nearest large crater is called Thabit, but curiously, the crater that the Straight Wall is embedded in has no name. You will notice if you can see my cursor, follow the arc of the crater rim here, and then it extends outward into Mare Nubium, where this outer portion, the western portion of this crater was buried by Nubian basalt flows, and you can still see the impression of the rim by the wrinkle ridges that are left. So we call this large buried crater, ancient Thabit. It's an unofficial name, but it identifies the region. A little Burt crater next to it, and then the Rima Burt that parallels the straight wall is a feature that up until about 20 years ago, most people couldn't see it. It shows up very well in high resolution lunar photography, but not so well visually looking through a telescope. So this has become a feature that has become popular just within the past 2 decades. Now, sunset on the straight wall presents some interesting imaginative scenarios. Consider that the straight wall is something like about 350 meters high. You're standing up on the rim of straight wall, looking at the sunset in front of you on, on Mare Nubium. On Earth, we're used to the sun going down quickly. We look off on the horizon 2 minutes from when the moon or the sun contacts the horizon, it's completely gone. It sinks out of sight. But the moon rotates much slower than the Earth. It takes 28 days to rotate. So sunset on the moon will take an hour. So the view up there will be spectacular for a long time, looking at sunset out across Mare Nubium from the rim of straight wall. Some volcanic features on the moon. These real structures, cracks in the moon, are all volcanic features. The Rima Triesnecker. Come on, I'm pushing the wrong button. Sorry about that. Rima Hyginus, which the gull-wing feature kind of centered on Hyginus crater. Hyginus crater is 9 kilometers in diameter, and it is the largest non-impact crater on the moon. It's actually a volcanic collapse pit. The heart of the moon, the mountainous regions just north of Rima Hyginus, very dark, ash covered with volcanic ash deposits. I call this area the heart of the moon because it looks like a heart. This region has no name, so I can call it whatever I want. And Rima Aridaeus off to the lower left, so straight on in places it almost looks like a highway excavation. Again, another feature called a graben, where the land collapsed between 2 parallel faults. Up in the northeast, here we've got the 2 lunar strongmen again that we were looking at sunrise a while ago, except now we can see them for what they are, Hercules, Atlas craters. But the show begins up here at Endymion, another of these Plato lookalikes or Plato wannabes that also filled up with basalt, and we no longer see the crater floor. Or further over on the horizon, Mare Humboldtianum, one of the large lunar seas that hugs the limb of the moon, and we never see we rarely see the entire lunar sea, but occasionally, at the right time, lunar libration, that is the periodic rocking and nodding of the moon, because the moon is in an elliptical orbit instead of a circular one. So it kind of wobbles around a little bit, and we eventually see 59% of its surface instead of just the 50% that faces Earth. So when that happens, here we have Mare Humboldtianum. We can see the whole thing, and we can see the horizon beyond it. And we can see even one more thing, the far side crater Compton, a little bump on the edge of the moon. This feature is actually at 110 degrees longitude, far beyond the normal range of being able to see things on the far side of the moon. But the high rim of Compton crater protrudes high enough that we can just see it poke above the horizon at the right time. Other volcanic features, the Marius Hills, well, Kepler crater kind of sets the scene here. The Aristarchus Plateau, very volcanic region built up by pyroclastic deposits well over 3 billion years ago. And the Marius Hills, when you see sunrise across here, it's this vast collection of dozens of little dimples on the moon. These are actually tiny shield volcanoes. Ghost crater. We see Mare Tranquillitatis here, Western Tranquillitatis, and the ghost crater Lamont, except we don't see the crater itself. It formed on Mare Tranquillitatis before the basalt flooding, and as the Mare filled with basalt, the crater was completely overrun, paved over, and now we only see it by the wrinkle ridges that are left, creating the impression of the crater. So we call these ghost craters. And the Apollo 11 landing site just south of Lamont. Now, moving along, the floor fractured craters. These are created by volcanic uplift that push the bottom, the floor of the crater upward. Some of them actually, the volcanic flows breach the surface, flood the crater. Others just simply lift the crater floor and heavily modify it, sometimes creating rills and cracks, such as the cracks in Petavius crater. Here we've got Rima Petavius, very distinctly radial, rill extending outward from the central peak to the rim. Posidonius crater on the northeastern shore of Mare Serenitatis, another floor fractured crater. Here we see both internal lava flooding and the rills and cracks created by the volcanic uplift. Oops. Yeah, there we go. let's name these things. And of course, down here, Le Monnier crater, inconspicuous in its own right, but for over 50 years, it was the site of the last explorations of the moon when the Russian Lunar 2 rover landed there in 1973. Of course, now we've got Chinese landers on the moon, and we are getting ready to go back to the moon. And who knows, maybe even one person in our audience may be one of the crew members on one of those missions someday. I pray. Serpentine Ridge, another wrinkle ridge out in Mare Serenitatis, one of the most prominent wrinkle ridges. Crater rays are the material splashed out of the crater by the impact that creates the crater. The rays around Tycho, Copernicus are very famous. Some of the brightest craters on the moon are the rays around the fairly small craters, Stavridius and Furnarius A. These are very young. Crater rays last no more than about 1 billion years before space weathering erases them and makes them fade. So if a crater has rays, we know it is a fairly young one. Another form of ray structure is the butterfly ray pattern, such as around Proclus crater here between I'm drawing a blank. I'm getting tired. Anyway, Tranquillitatis and Crisium. There we go. I can't read the title. I can't cheat because it's hidden behind my own picture on my screen. Anyway, Proclus crater. Very distinctly different type of rays. They fan out in linear directions, and there's a zone of avoidance where there are no crater rays. This happens when the impact is at a very shallow slant angle, less than 5 degrees. The crater ray material is splashed out laterally or downrange, but none of it goes backward in the direction that the impactor came from. I mentioned not all craters are round. We've got Rada E, distinctly keyhole shaped. Valleys on the moon. This particular one, the Rada Valley, technically spans the entire picture, but I disagree on it being a continuous same feature. Midway down, we see the Rada Valley is named after the crater Rada, which is near the northern end of the valley. But midway down, we see the Mallet Valley, the crater Mallet, right at the dogleg of the Rada Valley. I don't think these are both the same feature. So I think the bottom part should really be called the Mallet Valley. But I am not king of the moon, so I don't have that authority. Lunar mountains are actually the rims of impact basins. Mountains on the moon do not form from volcanic eruptions or plate tectonic activity like they do on Earth. So surrounding Mare Imbrium, we have the lunar Alps up near Plato crater, the Caucasus on the east, the Apennines sweeping down toward Copernicus crater. Scarps on the moon, in this case, the Altai Scarp, which arcs around the southwestern region of Mare Nectaris. This is actually the surviving section of the outer impact ring of the Nectaris basin. All the other parts have been obliterated by subsequent impacts over the past 4 billion years. But here we see very prominent 2-kilometer high cliffs rising up very distinctly. Now, getting to the conclusion, there are people who say the moon is boring, it never changes, it's always the same. Well, I disagree. Just within the space of 2 hours, this view of Ptolemaeus crater shows significant changes in the shadows. This is just over a span of a mere 2 hours. So if you follow the Terminator, follow the shadow, it is never the same 2 nights in a row. The moon will always put on a delightful show no matter what phase it is. There's always something new to explore. And if you understand what you're looking at, if you understand how these features were formed, how they interact, how they relate to each other, and how they were formed and modified by volcanic forces, the moon takes on a whole new personality. It's not just a ball up there with bumps and holes in it. It's a whole new world that is showing us live to our face how it was created. And the moon is the only world that we can observe with our home telescope and get kilometer resolution. So, oops, should be progressing along with my text, but I get carried away. So let's conclude this by saying there is much to love on the moon, and I ask you to join me on my playground. Come out and have fun with me with the moon. So that concludes my talk, and if anybody has any questions, I'd be very happy to chat with you.
Thank you, Robert. That was absolutely fascinating, and all these comments we have on the chat here. Really appreciating everything you've done here. It's phenomenal. We do have a couple of questions.
Okay.
And let me go through here. Let's see. We had a visual. We had Kate. You asked about is there a good light pollution filter for visual astronomy? You did get some answers in the chat. Before we go on to Robert's questions, though, I would say that we do have, I think Stephen Jones even made a novice talk on selecting light pollution filters. So broadband, narrowband, comet filters, all kinds of things. So do log into the website and search on there for some good advice there. Let me see now. We've got, let me open this up a little bit better so I can read this. Bob, you had a comment and a question, Bob Gillespie. Would you like to come off mute and ask Robert this?
Sure. Can you hear me?
I can.
I'm remembering your talk 2 years ago, October. Welcome back.
Oh, well, thank you.
Incredible photos. At that time, I kind of got the impression that once you had gotten some other projects out of the way, that you might consider a book of your photographs.
Well, how many of you are on Facebook and look at the moon pictures that I do every day under the theme of Postcards from the Moon? you're actually seeing kind of a prototype of such a book. But one moment, it's behind me. I moved it. I know all of you know the publishing firm, knew the publishing firm Wilman Bell. They did my first, well, my 3 astrophotography books. They asked me to write a book about the moon, which I did. And it was rather large, 3 volumes. I called it Men, Machines, and the Moon. One about the people involved with lunar explorations through the ages up to the space age, machines, the robotic exploration of the moon before Apollo, and the moon, which detailed the moon. Well, they decided, no, we don't want to do something that big. So we chopped it down to just the moon part, the last part. I have the other 2 manuscripts gathering dust. And we progressed along, and Wilman Bell started to wind down, and they pulled the plug and closed up shop before my book was published. So I do have, let's see if we get it up here. I do have a 300-page book written about the moon that's waiting for a publisher, and I just don't quite know how to approach it. So the book is written. So
Wonderful. We have another question posed by Debbie Moran. Debbie, would you like to come off?
Sure, thanks. So Robert, if you could go to the moon, putting all practicality aside, is there a feature you would like to see in person? And would that be a smaller feature that's more, that can be better perceived by a human being?
Robert, we're not hearing you.
okay, I'm sorry, I mashed
Here
my
we
mute
go.
button.
Yeah.
I had mashed my mute button when I turned around. No, back in the 50s, I was very fascinated with the straight wall because Chesley Bonestell, the famous space artist, depicted it as this imposing sheer cliff. And as the space program came along and we were able to get a better look at it, we realized it's not the sheer cliff that it is, but a steep slope. But that feature is remains stuck in my head. There's so much volcanic tectonic activity around there that this has got to be a good place to explore various aspects of the moon, not just prowling around in the crater, but we've got other things going on here that I believe deserve exploration. So I would very much like to be one of the first to traverse the straight wall, descend it. It's a steep slope. It's not a cliff. I truly believe that a future very spirited astronaut could walk down carefully the straight wall, and I would love to do that.
Amazing. Do we have any other questions? I think we've all been so mesmerized by your photos.
or they're asleep.
Or no, not at all. And in fact, I was so mesmerized by your pictures. Did you speak as to how these other shapes of craters came about? I'm fascinated by the square one, rectangular ones.
Well, the W bond, the square one, it was of course modified by subsequent impacts that scrunched the corners up a little bit. It didn't form that way to begin with, but it was more roundish 4 billion years ago. Trust me. But
so over time, these are just things that we'll see.
They can be modified by subsequent impacts, the seismic activity of subsequent impacts, but the surface strength of the material that forms the surface of the moon, be it rock, be it layered basalt, be it crushed breccia, the strength of it has something to do, or a lot to do, with how a crater appears. Look closely at almost all craters are not round. they have certain linear segments. And this is driven by how the shock wave progresses through the material, whether it's dense rock, loose soil. The famous meteor crater in Arizona. Take a good look at it. It's very squarish looking. It's not round. And it's a function of the material where the impact occurred. How the shock wave progresses through the ground.
Oh, I am due for another trip there. I'm going to have to see that. Oh. Do we have any other questions for Robert? Well, again, we were just all floored in the comments about your presentation and your photos and what it must take to do this.
Well, it takes time like any other project. You're not seeing the results of something I did in 1 week or 1 month.
No.
These photos have been progressing over a decade because it takes good seeing. And good seeing, as you know, in Houston is a precious commodity. In fact, in the entirety of 2022, I have not had seeing that would allow me to take a lunar photograph from San Antonio. I pray that this is a temporary situation and not a climate change that's going to continue to plague me. But it does rely on very good seeing to get this kind of detail.
Well, Robert, we really do appreciate this presentation. It was fabulous. And anytime you want to talk to us, we'll be there.
Well, hopefully a future presentation in person where I can enjoy meeting my friends again and doing it in person. You know, the future is ahead of us, and I don't plan to go away.
Right. Good. Me neither. All right. Well, good night, everyone. And I can hardly wait for Joe to put this online for us to view again.
All right. So, it's been fun. Thank you very much.
Thank you. Bye-bye, everyone.
Bye-bye.